Graph data with appropriate scales and variables on correct axes. Graphs are a quick visual way to see data relationships. So when we talk about a data relationship, we're talking about all those data points. Is there a trend upwards? Is there a trend downwards? A more specific way is to say, is the slope positive? Is the slope negative? For example, if we look at this graph here on the right, you can see that there's this trend that goes like that. We can see the relationship between hours of study and test scores. There's a direct relationship there. All right, be sure, be sure to recognize the difference between a data table and graph. This up here is a data table. This is a graph. Just make sure that you know how to tell the difference between a data table and a graph. Data table. A data table should be labeled with variables and units. Variables and units. For example, here is our data table. Here's the variable, and the unit is years. On the y-axis, the variable is average radius, and the units are in centimeters. If we look at this graph, test scores, they don't have a unit. I don't know, points maybe? We could fill that in, points. I like to put my units in parentheses. That's the proper format for that. When drawing on a graph on graph paper, please make the graph take up at least half the page. At least half the page. At least half the page. So if this was your graph paper and you were drawing your graph on here, yeah, you should have a big old honking graph. That way your data points all make sense and it's nice and neat. And I can see the relationship clearly. If you are given a graph to graph in, make sure that your points fill up 75% of the grid squares. Grid squares. What are grid squares? There are these little boxes down below. Grid squares. This is a grid square. This is a grid square. This is a grid square. So there are these little boxes. What does that mean, though? So if you're making your graph, say if this is your y-axis and this is your x-axis, your points should not look like this, and then you're done. Your graph needs to take up more space here. So that means that you must have done a scaling error. We'll talk about what that means. You didn't scale your graph correctly so that your points take up the whole space. So we want our graph to be taking up most of the grid, both lengthwise on the x-axis and vertically on the y-axis too. So we'll show you guys how to scale correctly. This is a 10 by 10 grid. This is a 20 by 20 grid. Just see what the difference is there. Graphing a data set. So here we have a variable and a unit, the x and y axis. Let's look at the steps to graphing a data set. Step 1. Correctly label the axes. Data from the right column is plotted on the y-axis, and data from the left column is plotted on the x-axis. So y and x. Data on the right column is the y, you know this, and data on the left column is the x. So we want to label this on our graph. This is always the y-axis. The best way to remember that is you could draw like a really big silly y, and that's how you remember that. This is how you'd label this if it was math class, but in physics class you actually have to write the variables. So the variable on the x-axis was time. The units were in minutes, and the variable on the y-axis was temp or temperature, and measured in degrees Celsius. Oh, I forgot my parentheses. Good to have standard notation. Okay, so we got labeled axes. Next, step 2, correctly scale your graph. That means that each box needs to represent the same amount. What does that mean? Okay, so if I'm correctly scaling my graph, that means that each box, this from here to here, that needs to be the same amount for each grid square. So if this is 1 and this is 2, then this needs to represent 1 minute. This needs to represent 1 minute. This needs to represent 1 minute. So that this point here is a 3, and this is a 4. See, makes perfect sense, right? Each of these has to be evenly spaced so that each square represents the same amount. But we haven't really scaled this guy yet, so let's not jump ahead. Okay. Strategy number 1. So how to scale it. Eyeball it plus the guess and check method. So we're going to do the eyeball it plus the guess and check method. So we want to find the highest number and count out evenly so that all the points fit. So the eyeball it plus the guess and check method. Find the highest point. Or lowest point if we're thinking about a negative number. Find the highest point. Okay. So let's do this y-axis here. So the highest point is 80 degrees Celsius. And the lowest point, some people would think it's 40, but that's not right. The lowest, or 45, the lowest point is the origin of the graph, because we always in physics class start at the origin in our graphs, which is going to be 0 degrees Celsius. And then somewhere up at the top, we need 80. Like 80 should fall here at the very top. Oh my gosh, that would be perfect. Or, you know, somewhere in this range, in this area. If 80 is down here, then we're not going to be using this whole top of the graph, and then we would have a scaling error, and that's bad. So this 80, we need to have the 80 end up there. So what I always do is I just sort of eyeball it. I like kind of mark out a number of spaces, and I think, okay, what could I go by? Like maybe 20, 40, 60, 80, sort of. Let's try counting. We could count by, I don't know, 5s. So let's count by 5s. 5, 10. So I could skip every one and go by 10s. So 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, and 80, it didn't hit at the very top, but you know, we're still using most of our graph, and so that is good enough. So if you only have this amount of your graph that you're not using, you still get full credit on these graphs. Okay, so that we called the eyeballing it and then guessing and checking. So you can always guess, and if you don't have a good scale, then just erase and go again. That's why we always use a pencil. Next, strategy number 2. Points per grid square plus the round up method. Points per grid square plus the round up method. So points per grid square. Grid squares, we can call it. Okay, what does it mean? Divide the highest point by the number of grid squares. Round up to the nearest whole number and count by that number. Wow, that doesn't quite make sense to me. If I just read it out loud, I have to do that. I have to perform that function until that's going to really make sense to me. Divide the highest point by the number of grid squares and round up to the nearest whole number and count by that number. Okay, let's just follow this instruction as true to the word. Divide the highest point by the number of grid squares. Okay, so let's do this x-axis here. On the x-axis, the highest point is this 33. So we'll take 33 and divide that by the number of grid squares. So how many grid squares do we have here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grid squares. So we're going to divide by 10. The highest point divided by the number of grid squares. 33 divided by 10, well, I know in my head that that's 3.3 because I'm good at working with those numbers like 10 and 100 and all those. But if you don't know that, you can just use a calculator. That's fine. And then the next step, it said round up to the nearest whole number. I would usually round that down if this was math class, but I'm rounding up, so this is 4. Okay, this is my strategy here. So now I have 4. I'm going to count by 4s each grid square. So why did I round up? You'll see why I rounded up and not down. It's because I don't want to run out of space. If I rounded down, I'd go by 3s and I'd run out of space. But this method, it's going to just get me as far as I need to go and to make an acceptable graph. 20, 24, 28, 32. Remember, my highest point is 33, so we're going to reach it. 36, and then 40 up here. Again, we don't have any data that goes beyond 33, so that means that this whole back half of the graph we're not going to use at all, but that's okay. That's a small enough piece of these grid squares where I'm still going to have a successful graph. All right. Now we have correctly scaled our axes, and the last step, plot points, strategy, the over and up method. I'm going to just do a few points. I'm not going to do all the points just because I have a feeling all of you guys know how to do this from your previous science classes or your math classes. The over and up method, so if I look at my data set here, 0, 80, start at 0. I don't go over anything because it's 0. I go up to 80 and I put my point there on the graph. Go over, let me just jump up ahead, over to 13, up to 60. So I'm going to go over to 16 and up to 60, over and up, and I'm going to put my point right there. And let's just do one more, 33, 45. So over to 33, up to 45, boom. And I'm going to put my point right there at that spot, 33, 45. Of course, when you do it, I want you to grab all of your data points, but I'm just going to save some space on this video and not overly bore everybody, which I'm sure I already have. But I just want to make sure that you guys know how to make a beautiful, perfect graph. Maybe you guys have better handwriting than me. I hope so. But that's how it's done. Good work.